All right, 8th grade. So video 2 is going to focus on the converse of the Pythagorean theorem. So the Pythagorean theorem can only be used when you have a right triangle. And the formula is a squared plus b squared equals c squared. So our focus for this video is using what we know about the Pythagorean theorem and determining whether a triangle is a right triangle or not, okay? So if the sides of a triangle have lengths a, b, and c units such that a squared plus b squared equals c squared, then the triangle is a right triangle. If you reverse the parts of the Pythagorean theorem, you have formed its converse, okay? So I have two things here. I have a statement and I have a converse. So the statement says, if a triangle is a right triangle, then a squared plus b squared equals c squared. And the converse states, if a squared plus b squared equals c squared, then the triangle is a right triangle. So the converse of the Pythagorean theorem is also true. So this will make some more sense when we look at some examples. So here we go. All right, so we're going to use the Pythagorean theorem and its converse to determine whether these triangles with the given lengths of the sides form a right triangle. And we're going to justify our answer by performing the Pythagorean theorem. All right, so remember, like I said in the last video, your sides A and B should be your shorter sides because those are your legs. And your hypotenuse, which is the side across from the right angle, should be the longest side. So we know that the Pythagorean theorem is a squared plus b squared equals c squared. So what I'm going to do is I'm going to take these numbers and I'm going to plug them into my theorem. So if I look at them now, 60 is the greatest number, so that's going to be side C. That's my hypotenuse. Then I have 36 and 48. So I'm just going to say here's A, here's B, and there's C. Okay? So then we're going to replace our variables with those amounts. So I'm going to have 36 squared plus 48 squared is equal to 60 squared. Okay? Well, 36 squared is 1,296. 48 squared is 2,304, and 60 squared is 3,600. So what we're going to do is we're going to see if this equation is true. And if this equation is true, then we have a right triangle. All right, so 1,296 plus 2,304 is equal to 3,600. And does that equal 3,600? Because that's what we have on the right-hand side. So since both sides of my equation are equal, this is a right triangle. Because a squared plus b squared does equal c squared. And if these are equal, then that means we have a right triangle. So the converse really is that instead of us finding the missing side length, we're looking at three sides and we're determining, okay, does this fit? Does the Pythagorean theorem work with this? And if it does, then you have a right triangle. All right, so your second example, I have 4 feet, 7 feet, and 5 feet. All right, well, 7 feet is the longest, so that has to be my hypotenuse. And then I have 4 and 5, so it does not matter which one of those you pick to be A and B. So I'm just going to say A and B. So again, the Pythagorean theorem is a squared plus b squared equals c squared. So for A, we had 4, B, 5, and C, we had 7. So 4 squared is 16, 5 squared is 25, 7 squared is 49. Well, 16 plus 25 is 41. Does 41 equal 49? No, 41 does not equal 49. So since this is not equal, A squared plus B squared does not equal C squared. This is not a right triangle. So when you're using the Pythagorean theorem and its converse, you're just proving whether something is a right triangle or not. And by justifying your answer, you're just showing your work to show, yes, a squared plus b squared is equal to c squared, or a squared plus b squared is not equal to c squared. Okay? So if it's true, you have a right triangle. If it's not true, you don't have a right triangle.